Hey guys, welcome back to my channel. Today I'm going to give you a physical pharmaceutics 2 4th semester question and answers as per question bank of RGUHS. So we will start from the first unit, that is colloidal dispersion. 10 marks long essay. I'll start from the first question, that is discuss the electrical properties and kinetic properties of colloids. So the electrical properties have a subparts that are electrophoresis, electroosmosis, sedimentation potential, streaming potential, and Donan membrane effect. So the number one, electrophoresis, it is a phenomenon of a migration of colloidal particles for the dispersion medium, and it under the influence of potential difference. This technique involves the determination of the charge on the particle surface and the value of the zeta potential. So the design which is set up for the electrophoresis are electrophoretic cell, lamp, electrodes, and ultra microscope. So what is the method? In this method for the electrophoresis, and the electrophoretic cell containing two electrodes and a potential difference is applied and across to them. So this results in the migration of the charges towards the respective electrodes. The positive charge tends to the respective electrodes and move towards the cathodes, and the negative charge tend towards the anodes. Thus these signs of a zeta potential which can be determined, and the velocity v at which the migration of particles take place is directly proportional to the potential gradient, which is E, and across the particle, that is E, velocity is directly proportional to potential gradients. So the migration velocity v, which is equals to zeta potential, that is gamma, into potential gradient, that is E. So therefore gamma is equals to, so the zeta potential is equals to potential gradient divided by migration velocity. Number second, electroosmosis, it is a reverse of the electrophoresis method, where the particles are stationary by the making into a porous plug or by forming a capillary. The liquid then moves with respect to the charged particles. And the number third, sedimentation potential. In these methods, the particle starts to sediment and a potential diffusion is created. So number 4, streaming potential. In these methods, the particles are made into a plug and the liquid is forced through the plug. This results in the development of a potential difference across the plug. So number 5th, that is Donan membrane equilibrium concept. So the drug which shows the poor absorption that can be made to absorb readily with combining with a sodium CMC, which is an anionic in nature. Normally sodium CMC is a non-diffusible through the semi-permeable membrane. And the principle of Donan membrane equilibrium, it is a solution of a sodium chloride which is placed one side on the semi-permeable membrane, on the other side a solution of negatively charged colloidal particles. So it is placed, the volume of the solution on two sides of the membrane are considered to be an equal or in the equilibrium form. So the initial state of the semi-permeable membrane, this is the outside, which is A, inside, which is B, sodium, and there is a colloid R minus, outside A that has chlorine, and inside B it doesn't have chlorine, just it has a sodium. So sodium and chlorine can freely diffuse through the semi-permeable membrane, but it is the colloidal particles, this shows the poor diffusion. So in the equilibrium state, outside A and inside A, the colloid R plus sodium chloride, and outside A it doesn't have colloid R, just is having a sodium chloride, which is in the semi-permeable membrane at the equilibrium position. So number second, kinetic property. In kinetic properties, there are the subparts that are number 1, Brownian motion, diffusion, viscosity, sedimentation, osmosis phenomena. So number 1, Brownian motion. So this motion is seen in the particles of the size that 5 micron meter in diameter. So the Brownian movement works against the gravitational force. So the Brownian movement can be viewed in the light microscopes. So the velocity of the particles of the dispersed phase, it depends upon the size of the particles, and the Brownian movement can be decreased by increase in the viscosity of the medium. Number 2, that is diffusion. So the diffusion process may be defined as a movement of the particles from the higher concentration to the lower concentration until the uniform concentration is attained. So this phenomena can be well explained by the Fick's law, which is given in the equation. dq is equals to minus ds dc divided by dx into dt, where dq is amount of the substance which is diffused, and d diffusion coefficient, s area, dc by ds is concentration gradient, and dt is time difference. For the determination of molecular weight of the spherical molecules, the equation can be further modified as a d is equals to RT divided by 6 pi eta n, where the cube square root of 4 pi n divided by 3 mv, where m is equals to molecular weight, v is equals to partial specific volume. Number 3, viscosity. So the viscosity is defined as a measure of the resistance to flow of fluid which offers when it is subjected to the shear stress. So the principle for the viscosity can be applied to determine the flow properties of the particles of colloidal dispersion. The Einstein gave an equation to determine the flow property of the dilute colloidal dispersion that containing a spherical particles, which is eta is equals to eta naught 1 plus 2.55, where eta naught is equals to viscosity of the dispersion medium and eta is equals to viscosity of the dispersion. So number 4, sedimentation. So the sedimentation method can be explained with the help of Stokes' law, where V is equals to d square rho minus rho naught into g divided by 18 eta. So V is equals to velocity of the sedimentation, rho is equals to density of the medium, rho naught is equals to density of the spherical particles, and g is acceleration due to gravity. So where eta is viscosity of the dispersion medium. So that sedimentation is influenced by the gravitational force. This lowers the size limit of the particle, that is 0.5 micron meter, by applying the Stokes' law, where the sedimentation is not a kinetic property of the colloidal system but itself under a normal condition. So the ultracentrifuge is used to study the micellar properties of the drugs. Number 5, osmosis phenomena. It is to determine the molecular weight of the colloid, where the osmosis phenomena can be considered. Then the equation can be given as pi is equals to CRT, where pi is equals to constant, C is the concentration of the colloidal dispersion, R is molar gas constant, and T is absolute temperature. Moving to the next question, that is second question. Discuss the optical and electrical properties of the colloids. So optical properties, we have the sub parts, that is Faraday's Tyndall effect, electron microscope, scattering of light, light microscope, and ultra microscope. So I'll start from the first, Faraday-Tyndall effect. The colloidal solution, when it is subjected to a strong beam of light and the beam passes through, the result as a visible cone is formed when the particles of the colloidal solution scatters the light. So the visible cone thus obtained is known as Faraday-Tyndall effect. So the Tyndall cone can be observed with the help of ultra microscope. Number 2, electron microscopes. The particle size, shape, and the structure can be determined by using an electron microscope. The radiation source is a beam of high energy with having a wavelength of the radiation in the region of 0.1 angstrom. Electron microscope has a high resolution power. Smaller the wavelength of the radiation, the beam is greater the resolving power. It can also give a photographs of the actual particles. Number third, scattering of light. So this method used to study the proteins, polymers, association colloids and the liophobic solution, molecular weight of polymers and micelles, which can be measured by this method. If the particles are spherical and the scattering of light will be same in all the directions. If the particles are rod shaped, these tend to the orient themselves in a flow of liquid and give the different effect. So the principle for this is light source having a wavelength higher than the dimensions of the particle, which is used to the turbidity and which is measured from the scattered light by viewing a particular angle. So number fourth, light microscope. The light microscope is used in the visible light as it is the source of radiation, and it can resolve two particles if they are separated about 2000 angstrom. But the size of the particles in the range of the colloid, and hence the light microscope finds little use. So particle closer than 0.2 micron meter will be visible as a single blur. Number fifth, that is ultra microscope. It is being used to observe the Tyndall beam. In this microscope, the dispersed particles appear as a bright spots that dissolve polymer molecules and highly solvated solution particles, which do not scatter enough light to become visible. So for the electrical properties, you have to refer question number 1. So coming to the next question, that is third one, discuss the kinetic and optical properties of the colloid. For kinetic property, you have to refer the question number 1, and for optical properties, you have to refer the question number 2. So coming to the next question, which is fourth, what are colloids? Give example. Explain any 4 methods of preparation of different types of colloids. So what are colloids, or define colloids? A colloid is a kind of solution in which the size of the solute particles is intermediate between those in the true solution and those in the suspension. So example are butter, gelatin and jelly. The 4 methods of preparation of different types of colloids are mechanical method, peptidization, ultrasonic and condensation. So I will not read it, so you have to write in the notebook that this is mechanical method, peptidization, ultrasonic method and lastly condensation method. This is the principle. So moving to the next question, that is explain the different methods and preparation and purification of the colloids. So the preparation of the liophiलिc colloids. The liophiलिc colloids have a strong affinity between the particles and the dispersed phase and the dispersion medium. So therefore these colloidal solutions are readily formed by simply mixing the dispersed phase and the dispersion medium under an ordinary condition. So example gelatin, gum, starch, egg albumin, etc. So the liophobic solutions can be prepared by mainly 2 types, that is condensation method and dispersion method. In condensation method, the smaller particles of dispersed phase are condensed to be colloidal size. So this is done by the following methods, that are by chemical reaction, in that oxidization and reduction, hydrolysis and double decomposition. So number B, by excessive cooling and Number C, by exchange of solvents. So number D, by change of physical state. Number second, dispersion method. In this method, larger particles of the substance are broken into a smaller particles. So number one, mechanical dispersion, and number second, by electrical dispersion or bridge arc method, and number C, by peptidization, and purification of the colloidal solution. So the impurities are specially electrolytes which can be destabilize the solutes, so must be eliminated to make a colloidal solution stable. For the following methods, the commonly used purification colloidal solutions are dialysis, ultrafiltration, and ultracentrifugation. So number one, this is the dialysis. It is a process of separating particles of the colloid from those of the crystallinites by means of the diffusion through a suitable membrane is called as dialysis, and this is the principle of dialysis A, B and C. Number second, ultrafiltration. This is the process of removing the impurities from the colloidal solution by passing it through the graded filter papers, that it is called as a ultrafiltration paper. So it has an A, B and so the ultrafiltration may be prepared by soaking the filter paper in the colloidal solution, hardening by dipping the formaldehyde solution, and then finally drying it. So number third, ultracentrifugation. In this method, the colloidal solution is taken in a tube which is placed in the ultracentrifuge. So question number 6, explain different purification methods and protection of colloids. So the purification of methods of colloids, you have to refer question number 5. I'll start. Protection of colloids. So the lyophilic solutions are more stable than the lyophobic solutions. So the lyophobic solutions can be easily coagulated by the addition of small quantities of an electrolytes. So this phenomena preventing the coagulation of a lyophobic solutions due to the addition of some lyophilic colloid is called as a sole protection or a protection of the colloid. For protecting, the power of different protective colloids is different. The efficiency of any protective colloid is expressed in terms of gold number. So protective power that is directly proportional to the 1 divided by gold number. Mechanism of the sole protection. The actual mechanism of the sole protection is very complex. So however, it may be due to the adsorption of the protective colloid on the lyophobic solution protection particles followed by the solvation. So thus it stabilizes the solution via solvation effect. Number second, solvation effect can contribute much towards the stability of the lyophilic system. That is, example for the gelatin has a sufficient strong affinity for water. It is only because of the solvation effect, then even it is the addition for the electrolytes. So in small amount it doesn't cause any flocculations of hydrophilic salts. However, the higher concentration precipitation occurs. So this phenomena is called as salting out. The salting out efficiency of the electrolyte depending upon the tendency of the constituents ions that gets hydrated, and the cations and the anions can be arranged in the decreasing order for the solventing out power, such as arrangement is called as lyotropic series. So this is the synthetic protective colloid where it has the synthetic protective colloids were prepared by introducing an acidic group into the basic polyethylene molecules by introducing a basic group into the polyethylene amine molecules and polyalkylic acid molecules with some synthetic protective colloid. So the protective value can be increased as much as 100 times by the action of heat and as well as time. So the interaction between the protecting agent and the soil that can be protected and that requires a longer time than the three previously colloids formed. They are stable complexes with a coagulating metal ions. So the protective colloid that changes the strongly as well as pH for the narrow ranges with some polyamphiones and the protective values and the gold number of some protective agents are compared. So the protective values and the gold number some of the compared as a synthetic polyalkylic hydrazide which has the highest protective value of 400. So the synthetic polyalkylic hydrazide acid is the greatest at this point. So here we have completed the 10 marks first unit question and answers. Tomorrow I am going to give the 5 marks question and answers. So please do like, share and subscribe to my channel. Thank you very much.